Hello everyone, I'm now going to move on to some practice with integration of polynomials. In the last video I kind of showed you that you can just apply integration to each term in a polynomial separately and then kind of add them together or subtract them depending on the sign before each term. But here I actually want to get you seeing how this works in more depth. So just giving you more practice essentially with this integration. So I'm going to solve those definite integrals here and the antiderivatives or indefinite integrals down below. So let's start with this first one. So before we do that, we just want to find the indefinite integral first, because that gives us the generalized algebraic form we're looking for. So we know that is the same thing, but we need to solve this and dx, of course. So we know that if we take a constant, that would be the same thing as, actually let's start with this. So if you remember correctly, integrating x to the power of n means dividing it by n plus 1 and raising the exponent to n plus 1. So then here we would have x cubed, and that is essentially divided by 3. Right, so then that would be minused by 4x. Now you would get a constant. You would get a constant with integration. Remember, because we're assuming that if you're differentiating something, then integrating back a constant may have been lost, because that's what happens in differentiation. So we're taking this, and then we're minusing 4x plus c. And now this c doesn't have to be the same one, but altogether that's still a c, that's still a random constant, we don't know what it is. So we just write that minus 4x plus c. But because we're doing an indefinite integral, or a definite integral here, then we ignore the constant, and we just take the actual integral by, if you remember this notation, we take the upper bound here and the lower bound of the integral, and we can use a calculator, and I'm also gonna verify this to show you that the answers should be correct. So we take just this expression over here, and then minus 4 times that expression. Okay, so I'm going to take x to be 5, because that's what we do. We take the upper bound, we compute it, and then we minus the lower bound. So I don't know if you can see, but I am computing this. Then I get 105. Oh, silly me. Forgot to divide by 3. Okay, right there. So then we get 21.6 recurring, and that minus, when we take that answer minus what we get for 0, which should be the same thing. So that's our answer. That is our definite integral. Okay, now to this one over here. Let's now present it in a different form. So this is actually equivalent to this expression over here. And here we have x to the power of 1 over 2, half, because that is the definition of radical function of x. That's just x to the power of half. And now we have a power here, so we can compute it. So again, we do this expression over here first, and we raise the power by 1, so we get 3/2, 3/2. But we also divide by this thing over here, which means multiplying by 2/3. So now what we have, integral, is the symbol is not necessary here. If we ignore the constant here because we're doing a definite integral, so then again, and this is a constant, so we can just take it outside of this expression over here by the constant rule, but just because of common sense. 2.5, 3.5 and 2.5. So then to the power of 3/2, that minus by 2.5 to the power of the same. We do that, and then we times it, we multiply it by the aforementioned 2/3, and we get this answer over here. Roughly that. And now I'm going to do this one. I don't think I have time to do this one, but I think I'm going to let you do it in your free time. So this is just an indefinite integral. We don't need to walk out to bounds or anything. So it's just pure theory. So let's take a shortcut. Actually, I'll just do this one because this one seems quite systematic, but this one has something to it. So we know here that there's a coefficient of 2 in each term. So we simplify it. We just use a constant rule, because this is the same thing as the integral of those. So then we can just move the constant here when we have 2 times the integral of this thing over here. And then we get 2 times, what do you have here? If we integrate that, we get x to the 4th. Then we have to divide by 4, so we get... And by the way, this is just a little trick in maths, in integrals. People don't really like writing fractions with x's in terms of x in them, either in the numerator. So we tend to kind of multiply by a fraction that consists of only numbers, and that's just a stylistic thing. And that minus, because here we are dividing by 2 as well, and then a constant just becomes x. So that's brilliant. So then here we have half, because this is 2 divided by 4, so again, so 2/4 equals a half. And here, so here it becomes a half, and here it just cancels out. And that's our answer. Okay, so that is it, and we have a constant of integration, which everybody tends to forget over time. And solve this by all means, and I'll see you in the next video.